All right, CUET fighters, listen up. Let's talk about that one question in chemical kinetics that trips up almost everybody. You know exactly the one I'm talking about. It looks so simple, but it's a trap, and it's designed to steal your hard-earned marks. Well, today, we're not just going to solve it, we're going to master it. Let's do this.
So, take a look at this. 2A turns into 3B. Seems simple enough, right? How would you write down the rate of reaction? Just take a second and actually think about it. I bet an answer pops into your head right away, but be careful. Because right there, that's the trap. Seriously, something like 90% of students make a critical mistake on a question just like this. But after the next few minutes, you are going to be in the top 10%. That's a promise.
So what is it? What's the secret sauce? There is one tiny, easily overlooked detail that makes all the difference between an average score and a top score. We're going to find it together, but first, we gotta lay down some groundwork. So let's just dial it back to the absolute basics for a second. Before we jump into the tricks and traps, we need to be crystal clear on the core idea. What are we even talking about when we say rate of reaction?
At its heart, it's just about speed. That's it. How fast are our starting ingredients, the reactants, getting used up? And on the other side, how fast are the things we're making, the products, popping into existence? It's all about how much their concentration changes over a bit of time. Simple as that.
Okay, so let's shift our perspective a little. You've got to look at this from two different angles. You've got the story of the reactants disappearing, and you've got the story of the products appearing. They're two sides of the very same coin. And this is where things get really interesting. For reactants, right, their concentration has to go down with time. They're being consumed. But for products, their concentration goes up. They're being made. And this leads to a tiny but super important difference in the formula. Do you see that little minus sign in front of the reactant rate? Why on earth is that there? And this is the key. The speed of a reaction has to be a positive number. You can't have a negative speed, right? Well, since the reactant's concentration is decreasing, the change, which is final minus initial, is going to be a negative number. So what do? We just stick that extra negative sign out front to cancel it out, making the final rate positive. It's a common stumbling block, but that's really all there is to it. All right, time for the main event. This is the absolute heart of our discussion today. And listen, this isn't just another rule to memorize. This is your secret weapon. This is the one detail that 90% of your competition misses, and it's going to boost your rank.
Let's think about any general reaction, where A units of A turn into B units of B. You see those little letters A and B? Those are your stoichiometric coefficients. And let me tell you, they are everything.
And there it is, the big secret. You take the rate of change for A and you divide it by its coefficient A. You take the rate of change for B and you divide it by its coefficient B. You must divide by the number in front. Forgetting to do this is the #1 trap that examiners set for you in CUET. Don't fall for it.
Okay, just pause here for a second. Seriously, look at this formula. Let it sink in. How does this one simple idea of dividing by the coefficient solve that very first question I asked you? The whole answer is right there on your screen.
Okay, let's put it to the test. Quick challenge for you. If ammonia, NH3, is appearing at a rate of 4, what's the rate of disappearance for hydrogen, H2? Let's walk through it. Remember the rule. The overall reaction rate is the rate of NH3 divided by its coefficient, 2. So 4 divided by 2 gives us an overall rate of 2. Now we want the rate of disappearance of H2. That's going to be the overall rate times H2's coefficient, which is 3. So 2 times 3 is 6. The correct answer is C. See how that works? It's like a puzzle.
Fantastic work. Now, let's shift gears again. I want to talk about some easy marks that you can just scoop up from questions about graphs and units. Seriously, these are points you should never leave on the table.
When you see these graphs, it's actually super intuitive. If you plot a reactant's concentration over time, the line is going to slope down. Of course it does. It's being used up. And for a product, the line slopes up because it's being created. Don't overthink it. It's that simple.
Now, pay attention because CUT loves this stuff. If they ask for the average rate between two times, you just draw a straight line connecting those 2 points on the curve, that's a secant, and find its slope. But if they ask for the rate at one exact moment in time, you draw a tangent to the curve at that single point and find its slope. So, secant for average, tangent for instantaneous. Lock that in.
And one last thing, the units. The standard unit is moles per liter per second. Here's a pro tip. Always check the units in the question and the options. Sometimes you can eliminate wrong answers just because their units don't make sense. It's a lifesaver. Okay, it is time. We've built the foundation. We've uncovered the secret weapon. Now, let's go all the way back to the beginning and close that loop we opened. Let's conquer that problem once and for all.
Here it is again, the exact same question, but it looks different now, doesn't it? You're not just seeing A and B anymore, you're seeing the 2 and the 3. You know what you have to do with them.
And boom, there is your answer. The hidden detail was simply dividing by the coefficients. The rate is equal to the rate of disappearance of A divided by 2, and it's also equal to the rate of appearance of B divided by 3. Making that simple division is what separates the top scorers from everyone else. And now, you're one of them. You know the secret.
Okay, let's recap this lightning fast. Ready? 1. Rate is always positive. 2. Reactants get a minus sign to make it happen. 3. You will never, ever forget to divide by the stoichiometric coefficients. 4. Average rate is the slope of the secant. 5. Instantaneous rate is the slope of the tangent. Got it? Good. So now that you've totally mastered this, it kind of makes you wonder, right? What other simple topics are hiding these little secrets that can boost your rank? What's the next concept in kinetics that's giving you trouble? You did some fantastic work today. Seriously, keep this energy going. Keep practicing, stay focused on those little details that truly matter, and you will absolutely crush this section on your exam. You've got this. Keep going.